Assalamualaikum. My name is Muaz bin Amirul Nizam. My metric number is D2024-111-2283.
Hi, my name is Nur Nailihana binti Arshad. My metric number is D2024-111-2250.
Hi, my name is Nur Amira binti Hamzah. My metric number is D2024-111-2241.
Hi, my name is Nur Hazalina binti Muhammad Najam. My metric number is D2024-111-222 and 3.
Hi, my name is Nur Adania Shakira binti Kirudin. My metric number is D2024-111-2243.
Assalamualaikum and good day everyone. Today, our group is excited to present our studies on traditional wood carving or locally known as ukiran kayu. Wood carving is not just a decorative element, it is a master craft deeply rooted in traditional Malay vernacular architecture carrying over 500 years of rich history. It serves as a beautiful reflection of cultural identity, social status and spiritual belief within the community. If we look at its geographical roots and origin, the states of Kelantan, Terengganu, Pahang, Kedah, Melaka and Negeri Sembilan have been home to skilled wood crafter for generations. Interestingly, much of the design language is heavily influenced by Siamese carving motif, as these regions were historically connected to Siam. In fact, it is widely believed that this local carving art was originally introduced to the region from Patani in southern Thailand. Moving on to the its usage and function. Ukiran kayu beautifully bridges the gap between artistic expression and structural functionality. It serves three main purposes. First, ventilation or sinsian angin. The specific style you see here is an open-work carving technique known as ukiran tembok temus. It is strategically placed over entryways, window frames, or near ceilings to allow natural light and fresh air to flow freely, which is essential for climate control in our hot tropical weather. Second, aesthetic ornamentation. Historically, these intricate designs decorated the grand hall or serambi of palaces and residences of the nobility to showcase elegance. Today, they are highly sought after the elegant hanging display and modern room dividers. Third, cultural and Islamic expression. You will notice that the design focuses purely on floral and geometric motif. This strict avoidance of animal or human figures align directly with Islamic design principles which deeply shape Malay cultural crafts. Finally, let's look at the physical specification of the specific rectangular wood carving panel we choose for our study. Based on our physical measurements, the panel is highly precise and compact. It has a width equals to 22.3 cm, a length equals to 30.2 cm. The height or overall thickness of the timber is 2.7 cm, and it features a perfectly square 90-degree angles along its frame border. A perfect example of a ventilation panel that could easily fit into traditional window, transom or modern wall placements.
In the art industry, geometric elements are frequently utilized to bring structure and balance to creative work. In the context of curving, these elements serve as the foundational blueprint for symmetric pattern and repetitive motif. Beyond this very artistic word curving, did you know that it also applies the mathematical geometry? To understand this, we must look at the mathematical concept. A geometrical shape can be classified into two-dimensional and three-dimensional. A two-dimensional shape has length and width on a flat surface, where a three-dimensional shape has length, width and depth. They are distinguished by their characteristics such as side, edges and vertices. In this part B, we already identified the specific geometrical shape following with its concept, as well as the transformation in pattern and motif. So let's go! The first two-dimensional geometrical shape is the rectangle, which is located at the outer frame itself. It is considered a two-dimensional geometrical shape because it has four sides, four vertices and four right angles, while its opposite sides are equal and parallel. These match the definition of a rectangle, which is a quadrilateral where both pairs of opposite sides are parallel and all angles are right angle. In this curving, The rectangle forms the main structure and enclose all the decorative elements within the panel. The next two-dimensional shape is circle, which is located at the center of the curving and is surrounded by egg petals. It is considered a two-dimensional geometrical shape because it has a curved boundary with no side or vertices, while every point on its circumference is the same distance from the center. These match the definition of circle, which is a set of all points in a plane that are at a fixed distance from a given point known as the center. The circle acts as the focal point of the design. Another two-dimensional geometrical shape can be observed in the pattern of the flower core, which consists of parallelogram. It is considered a two-dimensional geometrical shape because each shape is a parallelogram, which by definition is a quadrilateral with both pairs of opposite sides are parallel. Each shape features 4 sides and 4 vertices formed by intersecting diagonal lines. Ultimately, the repeated arrangement of these shapes creates a grid-like texture. This quadrilateral pattern enhances the texture and appearance of the flower core. The only three-dimensional geometrical shape found in the wood curving is the rectangular prism, which can be identified in the outer frame of the panel. It is considered a three-dimensional geometrical shape because it has 6 rectangular faces, 12 edges, and 8 vertices. These match the definition of a rectangular prism, which is a solid consisting of 2 rectangular faces and 4 lateral faces, where each rectangular face has opposite sides that are parallel and have 4 right angles. The rectangular prism is formed by the thickness of the wooden frame. Its purpose is to provide the main structure of the curving and support all the decorative elements.
Next, I will present about section 2.2, the geometrical concept and measurement. About our selected topic, the ukiran bunga emas. Let's look at the shape, measurement, and their relationship with geometrical concept. First, we identify a rectangle shape that forms the outer frame of the carving. A rectangle has 4 sides, where the opposite sides are equal, and it has 4 interior angles of 90 degrees. The measurements are length equal to 30.2 cm, width equal to 22.3 cm. Using the measurement, the perimeter is calculated by using the formula 2 times the sum of the length and width, giving 105 cm. The area is calculated by multiplying length and width, which is 673.46 square centimeter. This relates to geometry because the perimeter represents the total boundary of the frame, while the area represents the total surface covered by the rectangular shape. Next is the circle shape, which is located at the center of the flower motif. A circle has 0 sides and 0 corners, and every point on the boundary is the same distance from the center. The measurements are radius equal to 2 cm, diameter equal to 4 cm, and angle equal to 360 degrees. The circumference is calculated using 2 pi r and give a 12.568 cm. The area is calculated using pi r square and is also 12.568 square centimeter. This shows the application of geometry because the radius determines both the boundary length and the space enclosed by the circular shape. The third shape is a parallelogram, which appears in the small decorative pattern of the carving. A parallelogram has 4 sides, 4 angles, and the opposite sides are equal and parallel. The measurements are side 1 equal to 0.5 cm, side 2 equal to 0.6 cm, side 3 equal to 0.5 cm, side 4 equal to 0.6 cm. Height equal to 0.7 cm. It also has angle 1 and angle 3 equal to 102 degrees and angle 2 and angle 4 equal to 78 degrees. Sum of interior angle equal to 360 degrees. The perimeter obtained by adding all the 4 sides giving 2.2 cm. The area is calculated by multiplying the base and height, resulting in 0.35 square centimeter. This relates to geometry because the equal opposite side and the height are used to determine the boundary and the space occupied by the parallelogram in the decorative pattern. Finally, the entire carving can be viewed as a rectangular prism, which is a three-dimensional shape. A rectangular prism has 6 faces, 12 edges, and 8 vertices. The measurements are length equal to 30.2 cm, width equal to 22.3 cm, height equal to 2.7 cm. The volume is calculated by multiplying the length, width, and height, giving 1818.342 cubic centimeter. This related to geometry because volume measure the amount of three-dimensional space occupied by the wooden carving, showing the relationship between length, width, and height.
So now I will present section 2.3, which is transformation in motif and pattern based on the traditional wooden carving design. In this section, I will explain the motif and pattern found in the carving and identify the mathematical transformation that can be observed in this design. The selected carving consists of decorative leaf, flower petals, and parallelogram geometry elements. The flower petals and parallelogram are considered motifs because they function as individual decorative units. When these motifs are repeated and arranged systematically, they form patterns throughout the carving. 3 main transformations can be identified in this design, namely reflection, rotation, and translation. These transformations contribute to the symmetry, balance, and aesthetic beauty of the carving. The first transformation identified is reflection. 2 flower petals are positioned on opposite sides of an axis of reflection. Both petals have the same shape and size, and one petal can be mapped onto the other through reflection. This demonstrates reflection symmetry in the flower motif. The second transformation is rotation. A flower petals can be rotated around the center of the flower by 133 degrees to coincide with another petal. During the rotation, the size and shape remain unchanged. This shows the rotational symmetry of the flower motif. The third transformation is translation. A parallelogram motif is shifted from one position to another without changing its shape, size, or orientation. Based on the diagram, the motif is translated 1 unit horizontally and 4 units vertically. Since only its position changed, this is classified as a translation transformation. In addition, another reflection can also be observed in the parallelogram motif, where 2 identical motifs are located on opposite sides of a horizontal axis. For the overall pattern, reflection symmetry can be clearly observed. The vertical axis passing through the center of the carving acts as the axis of reflection. The motifs on one side are mirrored on the opposite side with the same shape, size, and arrangement. This symmetrical arrangement creates balance and harmony in the overall carving design.
Lastly, I will present the summary and conclusion of our project on ukiran bunga emas. Throughout this project, our group studied a traditional Malay wood carving known as ukiran bunga emas. We first explored its history, culture, background, functions, and dimensions. We learned that wood carving is an important part of Malay heritage and has been used for hundreds of years in traditional houses, palaces, and mosques. From a geometrical perspective, we identified several geometric shapes within the carving, including rectangles, circles, parallelogram, and rectangular prism. We also applied mathematical concepts such as perimeter, area, circumference, and volume by using actual measurement of the carving. In addition, we analyzed geometric transformation found in the motif and patterns. Reflection, rotation, and translation can clearly be observed in the arrangement of the flower petals and decorative elements. These transformations create symmetry, balance, and aesthetic value in the overall design. In conclusion, this assignment has shown us that geometry is not only a subject that exists in textbooks or a classroom, but it is also present in many real-life objects around us. Throughout the analysis of ukiran bunga emas, we discovered how geometric shapes and measurement and transformation contribute to the structure and beauty of the traditional artwork. This project also helped us develop our observation, measurement, and analytical skill by applying the mathematical concept in a meaningful context. More importantly, it increased our appreciation of traditional Malay craftsmanship and cultural heritage. Overall, we have gained a better understanding of the relationship between geometry and everyday life. We now realize that mathematics play an important role in art, architecture design, and many other aspects of our surrounding. Thank you for watching our presentation. See you next time.